So these features that I'm showing you so far have relatively been built into Linux for a long time. These are features of the kernel. They've like I think this has been around at least since, like chroot has been around since the 70s at least, right? Namespaces I think are slightly more recent, but I think we're still talking 2000s-ish. You might want to fact check me on that, but I think that's about right. This last one is relatively recent. It was invented at Google. It's called control groups, right? So Google had a problem that they would like be running multiple different processes. They'd be running these, and like they trust each other, right? So they're not worried about like stealing each other's secrets inside of Google, right? So they were like, cool, we'll just run processes right next to each other. You run your web server, I'll run my web server. We won't have different VMs for them, right? We'll just have them in their like limited environments. And they kind of had this problem though, that like if someone on the Google Maps team writes a runaway process, that might kill like the Google Docs team's process, right? Because it kills the entire server, right? So what they wanted to do is they wanted to limit like how much resources that one of these processes would have access to, right? And basically say like, look, you get 1 core or you get 10% of this CPU, and then once you're out of that, I'm sorry, that's all you get, right? Because I'm not going to let you crash this other team's running process, right? So they came up with this idea of control groups, right? I think there was another name for it previously. Actually, they called it containers, is what they called it. But then that kind of started applying to more than just control groups, so they changed that to cgroups, right? So that's what cgroups are for. Is that it's this idea like I want to limit how much CPU you have, how much memory you have, how much like network bandwidth. Like there's a bunch of stuff that you can limit on. We're just going to be looking at CPU and memory, but you can do control groups for a lot of things, right? So that's where it came from, but then it turned out that this is a really cool and interesting idea, because now I can do these chrooted, unshared environments, and then I can assign control groups to them, and all of a sudden I have these contained processes that can't do anything besides what I tell them to do, right? So you can execute arbitrary amounts of code and do whatever you want, but the only person that you're going to screw over is yourself, right? You can't screw over anyone else, and that's kind of the idea with containers here. So again, like a more real life example, if we're running a hosting service, right, and we have, Bob and Alice that are running their servers like within our hosting environment, we don't want it so that Eve can connect it to the environment and start messing with the other people's processes, right? She could just drop like something that's going to peg the CPU at 100%, take all their resources, and bring down their servers, right? We want to prevent that kind of thing from happening. So we need to have it so that they have limited access to physical resources, or physical, because most containers are still run within VMs, right? There's multiple levels of virtualization here. But for all intents and purposes, we'll call these physical resources. How much CPU, how much RAM, those sorts of things. Okay, so I'll say that like this is a little bit more difficult to accomplish than the things we've done before. It's more technical in nature, so I invite you to just kind of bear with me a little bit. So the first thing we need to do is we need to say apt. This is again still within our Ubuntu VM or container. Apt get install, we're going to say -y, cgroup -tools, and we're going to install htop as well for some fun later. And neither one of those is very big. So we just installed htop, which is one of my favorite tools. This will actually give you like a nice visualization of what's going on with your computer right now. So even this container, I think my computer has 8 cores on it, or 6 cores, or something like that. You can see that this container in and of itself, using cgroups, only actually has technically access to 2, which is kind of interesting. And I have 8 gigs of RAM. This one only actually has access to 1.95 gigs of RAM. So it's actually using cgroups to accomplish this, right? This little container can't see anything else. Okay. Quit. Okay. So that's what htop is. I quite like. It's a fun tool, and you can use it on Mac as well. Okay, so the first thing that we're going to do is we're going to say cg create -g, and we're going to create a new control group. That's what this does, and it's going to limit on CPU, memory, I/O, which you type BLK I/O, devices, and freezer, Okay, and then we're going to say :/sandbox. Okay, this creates a new C group for us. So I'm going to come back over here to my other Docker container, and we're going to run that same unshared environment. Actually, we can just do it from here because I already ran it from here. So this one. So we're going to go back. We're going to have one of these go back into an unshared environment. Right? Exact same command that we ran before. So now this one is in an unshared environment, and now I'm going to go and actually assign a C group to this to control this one. Now, you have to run this from the host, right? You can't run it from within, like you can't say limit myself, right? I have to go back to the host and do it from the host. So I have another, you can see here, I can see my unshared bash environment here. So this is another process that I have connected to the same container. So I ran ps aux, and I can see here this bash right here is running. So what I need is I need this PID right here, 7607. This will be different for your computer, right? Because how it assigns the PID will be different based on the computer you're running on. So I need you to run ps aux, and I need you to find the bash, this one here, that's the highest one probably, unless you have multiple, right? So you can see here I have 104. 104 is probably the one that I'm actually doing right now, or it might have been the other one. Doesn't matter. You need this one, right? It'll come directly right after the unshare. So 7607, it'll be different for you. And then what I want you to do is I want you to say cg classify -g CPU, comma memory, comma blkio devices freezer :sandbox. If you can't tell, sandbox is the name of the control group I've created here. You can call it whatever you want. And then I'm going to put 7607. So now this bash and all of its children processes, right? Because processes spawn other processes. They're all part of a process tree, right? I'm saying everything inside of that process tree is now inside of this control group. Right now that doesn't mean anything, right? Because I haven't done anything. But we're about to. But if you want to see what's actually in there, we can say cat sys fs cgroup CPU sandbox tasks, and you can see here 7607, right? So we could actually just directly add to that as well, but that's what cg classify does for us, is it classifies that as inside of this control group. Okay, so I want to see how much resources it has, so I'm going to say cat sys fs cgroup CPU sandbox CPU.shares. And you can see here it has 1024, which means that it has access to a core, I believe. Oh no, this is the priority, right? So what you can say is like this is a low priority control group, right? So I can say that if this was like a 5, anything that was at 1024 would get prioritized above it, right? So if I have two competing things, it'll compare like what their priority is. Now let's get into actually limiting what's happening, right? So we're going to say cg set -r cpu.cfs period. I would invite you to just copy and paste this. I actually really don't understand all of everything that's going on with these. Like I said, control groups are kind of above my pay grade here. But 100,000 -r cpu.cfs quota. So what we're doing here is we're going to try and limit this to only use 10% of the available CPU, right? So it's actually going to be 10% of what's available in my container, or 10% of the 2 cores that this container has available to it. Equals, and then we're going to subshell this out to 5,000 times, or this might even be 5%. I think this might be 5%. get conf n, oh, that's a space, n processors and that's going to be for sandbox. Okay, so I recognize that that's a mess of a command, but the idea here is this particular C group, we said, hey, anything inside of this tree can only use 5% of the available processing power. Okay, and then we're going to do one more CG set. This one's a little bit easier to understand. CG set -r memory dot limit in bytes equals, and we're going to say this has access to 80 megabytes, right? Anything above that, it just runs out of memory. And we're going to say sandbox. Okay, and then here we can check it out. We can say cg get -r memory dot stat for sandbox. And this will output a bunch of stuff, but we can see here, this is the physical limit of what it could go to, but we're saying, hey, this is what 80 megabytes would be in bytes, right? This only has access to 80 megabytes. Okay, so now I'm going to say htop, just so we can watch. Right now, there's not a lot going on in my container, right? And you can see this is the PSOX down here. So now I want you to go back into your Docker container here. And I'm going to show you how to pin a CPU just for fun, right? Now, I don't recommend dropping a fork bomb in here. You have to do a bit more stuff to prevent fork bombs from taking over a computer because of how they work. So don't do that unless you want to crash your computer, in which case be my guest. So one of my favorite things in Linux is you can do yes, and all it does is it just repeats y forever, right? Or you can say yes, crap, and all it just says crap infinitely. So if I say yes into /dev null, which is just say scream into the void, basically that's the equivalent of what this command is. What this is going to do is it's going to pin the CPU for this particular process, right? It's going to take as much CPU as it possibly can. So if I go back over here to Docker, you can see here it's taking about 12%, right? Where's the yes? It's right there, right? Now, if this wasn't inside of this, this would totally pin the CPU for us, right? 100%. But because we're using C groups, it's keeping that contained within this like one particular C group. That's pretty cool, right? We've artificially limited this particular process, and despite the fact that it's trying to screw us over, we're just saying, nope. The only thing you can do is you can take everything inside of here and you can burn that, and then you're just out of luck after that. Cool? So let's do it for the memory too. Stop that, and we'll say, we're going to use yes again, but we're going to do some more fanciness, which honestly, I don't understand exactly what's going on here. I pulled this 100% off of Stack Overflow, like most of my code. But this is going to consume as much memory as it possibly can. But the idea here is it's going to continually fill our memory until it runs out of memory. So again, if we look back here at our hswap, you can see here our memory usage went up quite a bit, right? But this has 1.95 gigabytes worth of RAM, and it's only consuming about 80 megabytes of it, right? So you can see here, I think it'll show you, oh, there's the CPU percentage. Can I scroll down? There we can. So you can see here it's consuming 3.2%-ish worth of memory, right? Which is not a lot, right? Because we limit it to only 80 megabytes. And actually, since I didn't show you that with the other one, let's run the other one again, just for fun. We'll go back over here to this htop. And you can see the CPU here pegged at 10%. So we basically like created a container by hand, right? Not totally, like you still need Docker, believe me. But this is essentially what Docker is accomplishing for you underneath the hood, right? Again, it does more for you. It'll like create volumes and networks and manage a bunch of stuff for you. But at its core, the container system is this.
So Docker will handle all the cgroup?
Yeah. I would say most people that use Docker don't know what cgroups are. Because you never have to know, right? It just manages all that stuff for you. So now you can go and like be like snooty jerks to your ops people's like, I know what cgroups are. And then just walk away. That's what I would do. I probably should stop this over here. So just for funsies, let's try this. Yes into, so now I'm outside of my change rooted environment. And if I say yes into /dev/null, this might be painful. You can see here, it's totally pinning one of these cores. Because now it's outside of the cgroups, right? And again, if we go back and look again, it should be unpinned. So this is as far as we're going to go with like manually creating containers by hand. Like everything that I've shown you so far, this has been an academic exercise so that you understand what Docker is actually going to do for you. For the rest of the class, we're going to be using higher level tools that's just going to manage all this stuff for you. Again, I don't think you really ever need to know these things that I've shown you, but now that you do, you know exactly what's happening. And I think, again, if you understand the complexity of your tools, you embrace them, right? Now you understand what Docker is doing for you, you're going to be a lot more grateful that someone take the time to build Docker, right? Rather than, next time you have a Docker problem, you can just want to throw your laptop, at least you'll be a little bit grateful.